In the last lesson, we started writing our own Objective-C code to manipulate some objects that I created for you. But a lot of the project was already pre-made when we started. In this lesson, we'll fill in those gaps by creating our own app from square one. We'll be creating this tip calculator app. We'll start from the beginning and go through all the steps to create the app, just like you would if you would have had the idea for this app and wanted to create it for release in the App Store. Let's get started. Open Xcode and click on Create a new Xcode project. Since this is a single view app, the best place for me to start is going to be the single view application template. I'm going to call the project Tip Calculator. We could use storyboarding for this project, but I'm not going to. As we saw in the first lesson, storyboarding will allow us to lay out multiple views at once and visually add transitions between those views without writing any code. Since I only have one view in this project, I'm not going to use storyboarding. But I am going to use Apple's Interface Builder tool, which is just like storyboarding, except that I can't lay out multiple views all on one screen, and I can't easily do transitions without writing code. There's nothing wrong with using storyboarding here if you wanted to, but I want to show you how projects work when they don't use storyboarding. So make sure storyboarding is unchecked and click Create. The project structure looks similar to our last project, except that instead of a .storyboard file, we have a .xib file, which is called a nib, or sometimes called a zib file. Clicking on the nib file will take you to Interface Builder, which is going to look very similar to storyboarding. One of the main differences you'll see here is that we don't have an arrow indicating the entry point for the app like we had in storyboarding. That part of the app is now written in code. I'm going to start building this app in really small steps. The first thing we're going to do is create a label and set its contents through code. Make sure the label is selected and look at the Identity Inspector. The Identity Inspector shows the class of what we have selected. The class for this label is UI label. So this label can do everything that UI label class says it can do. If we click on the gray part of the view, we can see that it's a UI view. Now click on this box that has a pop-up that says Files Owner. This Files Owner icon represents what's going to create and control our view. Notice that the class of the Files Owner is the TAD View Controller. All the classes that start with the letters UI, like UI Label and UI View, are Apple's classes, but TAD View Controller is our own class. When we created the single view app template, Xcode set up a custom class for us called TAD View Controller. TAD View Controller isn't anything you can actually see visually when you're using the app. It's an object that tells the UI view what to do, and we can also connect the labels and buttons to TAD View Controller to tell those what to do as well. So the way we're going to make our app work is we're going to make TAD View Controller do things. So we're going to write all our code in these two files, tadviewcontroller.h and tadviewcontroller.m. The tadviewcontroller.xib file is what stores the information about what we do in Interface Builder. So the first thing we need to do is connect what we build in Interface Builder to our code. To do that, make sure your nib file is selected, and then go to the Assistant Editor. Now you should see tadviewcontroller.h in the code editing view. If not, select it here. Now we can hold down Control and drag from our label to our code to create code and connect that code to our interface. Make sure you drag so that you see a line between interface and end. Now we can configure the connection. We want to make this connection an outlet. An outlet will create a variable for this object that will allow us to read the object's value at any time and move it around or do whatever we want to it. You almost always leave these other values as is when creating outlets. Type is the type of object we're connecting to, which is a UI label. Storage is something we haven't talked about yet, But when creating outlets to user interface objects, there are very, very few cases when you would select something other than weak. And files owner is our TAD view controller object that will be created using the nib. Name the variable label and click connect. Xcode automatically generates some code that creates a variable for the text file called label. When we create labels here in the .h file, they can be accessed by any of the methods that we write in the .m file. Before, we created variables by typing UI label some label. Here, Xcode does it a little differently. Xcode uses this @property command because it allows not only any method in the TAD view controller file to access this variable, but it also allows any other object in the app to access the variable. It's the same as the hidden property for UI view that we looked at in the last lesson. Using this @property declaration makes UI label a property, so it sets up methods label and set label so other objects in the app can query view controller label and view controller set label. There's a second part to declaring variables like this, which is done in the .m file. Where @property sets up those methods, this @synthesize line is what actually creates the accessor and setter methods. Xcode creates this code for us when we drag it from our interface builder to the .h file, so we don't have to write it ourselves. Now there's a lot going on here in the .m file, so let's switch back to the standard editor so we can focus on the code. If we look over at the .h file, we can see that TAD view controller is a subclass of UI view controller. So that means this TAD view controller can do everything that UI view controller can do. Back in the .m file, all of these methods are methods from UI view controller. And by rewriting those methods in TAD view controller, we're customizing them. Look at the viewDidLoad method. Hold Option and click on it to bring up a summary of it in the UI view controller documentation. It says called after the view controller's view is loaded into memory. There's also a comment here that says do any additional setup after loading the view. So any code we write here is going to run when our view controller is starting up. This is where we'll write code to change our label. The first line in this method's already here. It says super viewDidLoad. This means when the viewDidLoad method gets called, it needs to do everything that's normally done by UI view controller, which is the superclass. When customizing methods that the superclass already does, you usually call the superclass with the same method and then start writing your own code. This makes sure that everything UI view controller normally does will be done before we do anything extra. So let's write our own code here. Type label set text hi. Since we define label as a variable in our .h file, it can be accessed by any method here in the .m file. And since we connected that variable to our interface, when we perform methods on the label, we'll be able to see those changes in the view. And we know that the label can understand the setText method because when we open the documentation for UI label, text is defined as a property that is an NS string. And as we remember from the last lesson, the @ and quotation marks in this line of code is shorthand for creating an NS string. Now let's run the app and see what happens. Our label has the text hi. Now I want to add a button that will change the text when we press the button. So let's drag a button onto our interface. And now I want TAD view controller to know when that button is pressed. So I'm going to switch to the assistant editor view, and I'm going to make sure that TAD view controller.h is showing. Now I'm going to drag from the button to the TAD view controller.h file. This time, instead of creating an outlet, I'm going to create an action. An action will let the button tell TAD view controller when something has happened. I can choose from the list of events when I want to be notified. I'm going to choose touch up inside because I want to be notified when the user has tapped and released the button. The name, I'm going to type button pressed. And all the other settings will almost always be left the same when creating actions. click Connect. So where before we connected our code to create a variable that would control what's on the interface, here we created an action. An action creates a method that will be executed whenever this button is pressed. Clicking Connect created code to declare the method here in the .h file, and it defines the method here in the .m file with the rest of our methods. So whatever we want to happen when the button is pressed, we'll write here in the .m file. Let's say that when the button is pressed, I want to change the label to say The App Dojo. So inside the button pressed method, I'm going to type label set text The App Dojo. Now let's run the project. When we press the button, the label's text changes from Hi to The App Dojo. Now let's take some input from the user and then display that in the label. Drag a UI text field object onto the view and create an outlet to our code so we'll be able to read what the user types in. Creating an outlet, make sure you see a line here in the .h file. If you see a highlighted blue rectangle, that means we're connecting an action to a method that already exists, and we don't want to do that. We want to create a brand new outlet. You can call the outlet whatever you want. Let's call it text field. About UI text field is it handles almost everything about the keyboard for us. We don't need to handle reading the keys that the user presses or showing the keyboard. We just need to ask our text field what's written in it. So far I've been telling you what methods to use when dealing with user interface objects, but we can't go through every method of every user interface object. And a big part of the App Dojo course is teaching you how to learn. So if UI text field was completely new to me, and I didn't know what method to use to read what was written in it, here's how I would learn that. I would go to Apple's documentation for UI text field, which I can get to by option clicking, or by going to the Help menu and selecting Documentation, and then searching for UI text field. Then I would read this overview section to get an overview of what UI text field does. Then I would scan through these methods and read about the ones I think might do what I want. Here's a property for text. That sounds like it might allow me to read the text the user types in, so I'm going to click on it, and it says it's the text displayed in the text field. I know since it's a property, I can set the text using a setText method, and I can get the text using the text method. So I'm going to get the text when the button is pressed by going to the button pressed method and typing text field text. We want to do something with the text, and since text is an NSString property that I'm getting, it's going to return an NSString. I need to store that string so I can use it later in this method. So let's create a variable to store that text. Now we're not using @property like we talked about before because we're only declaring this user input variable so that we can use it while we're inside this button pressed method. And the @property declaration is only for declaring variables in the .h file for use by all the methods and other objects. So let's set user input to be what the user has typed into the text field. Now let's set our label to display whatever the user types in. Now let's run the app. We can type in some text and press the button to change the text. I want to show you something else you can do with Objective-C. Instead of declaring a variable here, we can write nested method calls. So delete the user input code, and next to set text, type text field text. This will set the text of the label to be whatever text is in the text field. Go ahead and run the app. And we can see that we get the same result. Writing our code this way can just save a few lines of code. And you can even have a nested method call within another nested method call if you wanted. But if you go too crazy, the code can get confusing to read. So far, all the objects we've created have either been user interface objects that we create in Interface Builder, or an NSString object that we create with the shorthand @ and quotation marks. Now I want to show you another way to create an NSString object. And it's the same way that you'll create other objects later on. One other way to create an NSString object is like this: NSString alloc init. Notice the NSString starts with capital letters, so I'm calling the NSString class here. This line of code is two nested method calls. The alloc method sets aside memory in the iPhone for an NSString object, and then the init method puts a string in that memory to actually create our string object. There are several different types of initialization methods instead of init that we can use to initialize our string. To see them all, we can go to the documentation for NSString. I'm going to use the init with string method. This method returns an NSString object by copying the characters from another string. Okay, so since we're returning an NSString, let's create a variable to store that string. And now let's create the string by copying a string we create with shorthand. And now let's set the label's text to be the new string that we just created. And we can run the app. And we see that everything works. We press our button. The button pressed method gets called. Then we create a new string. And then our new string is set as the text. But that's kind of pointless right now, since we could have just written the shorthand out and not done the alloc and init. So let's use a different initialization method for NSString. Let's use the init with format method. Init with format allows us to substitute variables into a string. So I'm going to get the user input from the text field and then substitute that user input into a string. Here's how I'm going to do that. I'm going to type NSString user input text field text. This gets the text field user input just like we did before. And now to create the string, I'm going to say NSString alloc init with format. Let's talk about what I've done here with the init with format. The way this method works is that the %@ is a placeholder for the object that we put after the string. In this case, the object is an NSString. That is what the user types into the text field. Let's see how that works. Great, I can type in my name and the app says hello and my name because we're displaying this formatted string with the user input from the text field. So now let's start working toward our goal of creating a tip calculator. When the user presses the button, we want to get the bill amount that the user types in, then we want to calculate the tip, and then we want to display the tip in our label. So let's delete everything we have so far in the button pressed method except the user input. So now we have the user input string, but we need to convert that into a number so we can calculate the percentage. Let's look at the NSString documentation to see if there are any methods that will turn a string into a number that we can work with. I'm going to scan the method headlines until I see something that catches my eye. Here's getting numeric values. The bill amount is going to be a number with a decimal value, and that's called a float. It looks like if we use this float value method, it will return a floating point value of the string. And that's exactly what we want. I can see that that method returns a float value, so we'll have to declare a float variable to store it. Notice how in the method definition there's no star character here. That's because float is not an object, so when I declare the float, I'm not going to use the star. So now I have the bill amount as a number. To get the tip amount, I want to calculate 15% of the bill amount. So I'm going to multiply 0.15 by the bill amount. To do that, let's declare a new float called tip amount and set it equal to 0.15 times the bill amount. Now we want to display this tip amount in our label. But when we use the method setText on our label, that method requires an NSString. So we need to convert this float into an NSString. Float isn't an object, so it doesn't have any handy methods like NSString did. The best way to turn the float into an NSString is to create a formatted string like we did before when we made the label say hello and then our name. Here's how we'll do that. Before we used %at as a placeholder because that's the placeholder for an object. But there's a different formatter for float values, and that's %f. If you want to see a list of all the format specifiers and read more about this, you can go to Google and type in Apple string format specifiers, and then click on the first result. So now we have an NSString with our tip amount. Let's set the label to show that string. Now let's run the app. Let's type in a bill amount and calculate the tip. Okay, that looks like 15%. The only problem is we have all these decimal places here and I really don't want them. We can fix that by changing the string format specifier to %1.2f. This will give us 2 decimal places. When we run the app again, we can see that everything looks good now. Now, rather than just make the tip 15% automatically, I'd rather let the user control that. Let's do that with a slider. Drag a slider onto the view. and then add some labels to indicate what the minimum and maximum tip amounts are. Now click on the slider and select the Attributes Inspector. The Attributes Inspector lets us format UI objects. This is everything we can do to set up the slider without having to write any code. We want the tip amount to be 0 and the maximum to be 0.30. And let's set the current value to be in the middle at 0.15. And now let's create a slider outlet so we can write code to access the slider's value. Now in the button press method, I want to get the value of the slider and multiply that by what the user typed in order to get the tip amount. Getting the float value of the slider is easy. I'll just use the slider's value method, which will return the float value of the slider. I could create a variable to store this value and then multiply that variable by the bill amount. But to save a few lines of code, I'm just going to add it into the equation that's already there. This line of code will get the value of the slider, then multiply that value by the bill amount, and then store the result in tip amount. The rest of the code that displays the tip amount can remain the same. Let's run the app. We can see that we can move the slider and calculate different tip amounts. It's hard to see exactly how much we're tipping though. We just know it's somewhere between 0 and 30%. So let's add a new label that updates whenever the slider is moved. To do that, I'm going to switch back to the Assistant Editor and control drag from the slider to the .h file to create an action where the slider changes its value called valueChanged. And I actually just made a mistake there. I accidentally created an outlet when I wanted to create an action. And I already have an outlet for this, so this extra outlet's useless. Let's delete all the value changed code that Xcode generates when we created that outlet. That's the @property method, the synthesize method, and this set value changed to nil line, which Xcode generates to let the app know that we no longer need something when the view unloads. Now just to make sure we didn't break anything, let's run our code again. And this is what it looks like when something goes wrong. Xcode's giving us an error. We can read more information about it in the debug area down here. You can make sure your debug area is open by clicking this view icon. There's a lot of information in bold about our crash. It says the reason is TAD view controller tried to set a value for an undefined key. And then it talks about the key being value changed. But we already deleted all the code for value changed. And the reason this crash occurred is because even though we deleted all that code, when we drag from Interface Builder to the code, that connection that we dragged still exists, and we need to delete that. All the connections we make are shown in the Connections Inspector in Interface Builder. Click on the slider and click on the Connections Inspector. See how there are two referencing outlets, one for value changed and one for slider? These are the outlet connections that we made to our code. Let's delete the one for value changed. Now we can run our code and everything's okay again. So let's make that action for real this time without making any mistakes. I'm going to control drag from the slider to the code to create an action for the event value changed, and I'm going to call it slider changed. So every time the value changes for this slider, the slider changed method will be called here in TAD View Controller. We can click on our slider and open the Connections Inspector to see that there's now a connection between the slider changed method and the value changed event. Now let's add a label to display the current tip amount. And let's connect that label to our code and call it current tip label. And now we can write code in the slider changed method to update this label whenever the slider changes its value. And it's very similar to the way we displayed the tip string when we calculated our tip. So now as we change the slider value, the tip label changes as well. We just need to do a little formatting to make it look right. Let's multiply the slider amount by 100 to make it a percentage, and then we'll add a percentage sign at the end. Since percent is a reserved character, the way we print out percent is to write %%. Let's run that and make sure everything looks good. Now there's one more thing I want to add. If the user hasn't typed anything into the bill amount text field and they press calculate, I want to let them know that they need to type something into the bill amount first. So let's go to the button pressed method and check to make sure that the bill amount isn't empty. We'll do this with an if-then statement. Under the user input variable, type if, and if your code completion dialog comes up here with the if-then, then you can just hit enter, and Xcode will fill out the syntax for an if-then statement. If this is your first time programming, an if-then statement just checks to see if a condition is true, and if it is, it will execute some code. We'll put the condition here in parentheses and the code in the brackets. The condition we want to check for is to see if the string in UI text field is empty. One way we check for an empty string is to see if the string's length is 0. So let's type in user input length is 0. And now I need to move my user input variable declaration above the if-then statement so that my if-then statement can understand what user input is. Notice I used the double equal sign in my if statement condition. This checks to see if two things are equal. If I just use one equal sign, then the app will try to assign a value of 0 to the length, which wouldn't work. If I want to check to make sure the length is anything but 0, I could type in exclamation mark equals. And if I want to check to see if the length is less than 0, I could type in less than 0. I'm going to leave the double equal sign so the if-then statement will check to see if the length is equal to 0. If it is, then it will execute the code that we typed in brackets. Apple provides something called a UI alert view, which makes it really easy to alert the user that something's wrong. Let's create a new UI alert view and put it in a variable called alert view. Alert view has a really long initializer method. Xcode knows what I want to type in, and if I hit enter when the method name is highlighted, it will pre-populate the method name for me, and I can fill in the values. For the title of the message, I'm going to type bill amount. For the message, I'm going to type you forgot to type in a bill amount. We'll go over delegates in the next lesson, so put nil for now. Nil is Objective-C for saying no object or nothing. Make the cancel button title say OK. And put nil for other button titles, since we don't need any other buttons other than one dismiss button. Now we can add the code alert view show to show the alert view. The alert view will automatically be dismissed when the user presses the cancel button. Now there's only one problem. Our if-then statement doesn't just stop this button pressed method right there. It's going to execute our conditional code and then keep going through the rest of the method. So to keep that from happening, let's put in an else statement and then encapsulate the rest of our code. So now if the length of the string is 0, this code will execute. Otherwise, the code after the else statement will execute. Let's see how that works. Great, now we've got a fully functioning app. Now let's add some UI details. I have a couple of UI images prepared for the background and the button. We can drag those into Xcode to add them to our project. Let's start with the button. In Interface Builder, I can go to the Attributes Inspector and change the image that the button uses for its default state to be the calculateButton.png image. Then I hit Enter, and I can select the button and hit Command equals to resize the button to be the same size as the image. The only problem here is that I still have Apple's rounded rectangle underneath my image, and I don't want that. So I'm going to change my button type to Custom. Then I'm going to hit Command equals one more time to resize the button and make it the same size as the image. And now our button's ready. Now to add the background, I'm going to create an image view. And in the Attributes Inspector, I can set the image for this image view to be background.png. Now I can hit Command equals to resize the image view just like I did with my button, and I can place the image to take up the whole screen. I want the background to be behind everything else though, so to do that, I'll make sure my background is selected, and then go to Editor, Arrange, Send to Back. Now I can rearrange things to put them precisely in place. I'm also going to add a label that says bill amount to let the user know what the text field is for. And I'm going to change some of these labels to have centered text in the Attributes Inspector. Let's run that and see what it looks like. Everything looks good. Now when designing user interface graphics, there are two types of iPhones you need to watch out for. There are normal displays, and then there are Retina displays. Apple's Retina displays have twice the amount of pixels per inch, and they allow you to specify a higher resolution graphic for each image that you use in your app. Apple makes it really easy to add graphics for Retina displays. All we need to do to support the Retina display is add into our projects images with the same name that have @2x at the end of the file name. So for this background image, background.png, I need to add an image that's twice as big called background @2x.png. So I've got that right here, and I'm going to add it into the project. And that's all we need to do to add higher res graphics. We don't even need to adjust the image view settings. So if we switch to the iOS simulator and change the hardware to iPhone Retina display, then we can run our project, and what we see here is the background @2x image. The difference between the high res and the normal res images are really subtle. So to prove it to you that this was working, I put a 1 pixel wide red line here in the @2x image. And that's not on the normal background image. So if we switch our hardware back to the normal display iPhone, we can see that there's no red line there. While we're here, let's go ahead and drag in the 2x image for our button as well. Note that we could still see our button in the Retina display even though we didn't have the 2x image. That's because all the higher res graphics are optional. If you don't want to add the higher res images, then you don't have to, and the Retina displays will just scale up the normal images. Now let's also add an app icon. The app icon is similar in that you want to have a 57 by 57 pixel icon for normal displays, and then an icon that's twice that size for the higher resolution displays. So let's add those into our project. To actually set the icon, we'll go to our project settings and then click on the target, which is our app, and then select the info settings. This is where we can set different properties for our app, like the launch and display settings. One of the properties is icon files. Expand that property by clicking the arrow next to it. Then click the plus icon and name the first item icon.png. Now add another item and make it icon at 2x.png. Now when the user has this app on their iPhone, iOS will look at the app properties and then look at a list of the icons and display the appropriate one. And now if we go into our app summary, we can see that our app icons are now filled. Now let's delete the app off the iPhone simulator to reset everything. And now we can run our app. And then when we close it, we see that we have the icon here. So now we have a fully functioning tip calculator with graphics and everything. And if we wanted to submit this app to the App Store, we could do that. And I'll show you how to do that in a future lesson. Between now and the next lesson, try to change the max tip amount on the slider to be 40%. But instead of using Interface Builder to change the max amount, change it in code. Also, see if you can find the Attributes Inspector setting for the text field that will make the keyboard display numbers instead of letters when the user taps on the text field to start typing in their bill amount.